Hello everyone. Today we'll see about introduction about matrix, and this is definition of matrix. An M by N matrix is a system of Mn elements arranged in a rectangular array or arrangement of M rows and N columns. Matrix is written like this: A is equals to A11, A12, A13 up to Amn. A21, A22, A23 up to A2n, and A31, A32, A33 up to A31. And in this matrix A11, A12, A13 up to Amn are called elements of matrix A. Element of matrix A. These are elements of matrix A. In the element Aij, I indicates row and J indicates column. Matrix A is equals to matrix A Aij M by N. I is equals to 1 up to M and J is equals to 1 up to N. Here the M by N indicates size or order or dimension of matrix A. And if the matrix A is said to be square matrix, if and only if M is equals to N. If a matrix A is square matrix, if and only if M is equals to N. The sum A11, A22, A33 up to Ann is called trace of square matrix. Therefore, simply trace of square matrix is the summation of diagonal entities, isn't it? The summation of diagonal entities shows the trace of a given matrix. An M by N matrix is called null or zero matrix if all its elements are zero. Then the next topic of this matrix part is type of matrix. Type of matrix, here we seen 8 type of matrix. From that, the first type is row matrix. Row matrix is a matrix that has exactly one row. Row matrix is a matrix that has exactly one row. Example of row matrix: A 5, 2, -1, 4. This is row matrix because it has a single row or one row. This matrix order or dimension of the matrix A is 1 by 4. 1 by 4. A is row matrix of order 1 by 4. This 1 by 4 indicates row. Indicates row or size of matrix A or dimension of matrix A. This 1 indicates row, this 4 indicates column. And the second type of matrix is column matrix. This column matrix is a matrix that has exactly one column. For example, B is equals to 3, 1, 4 is a column matrix because single column. 3 row. 1, 2, 3. 3 row and 1 column. Therefore, this matrix B is a column matrix. The third type of matrix is zero or null matrix. Zero or null matrix is a matrix whose entries all are zero. All the entries are zero and denoted by this 0 M by N. This M indicates row and indicates column, or simply 0. This 0 indicates zero or null matrix. Example: 0 is equals to 0, 0, 0, 0, 0, 0, 0. This means 2 rows and 4 columns. 2 by 4, 0 matrix. Simply 0 or null matrix are matrix whose all entries are 0. The fourth type of matrix are square matrix. Square matrix is type of matrix whose number of column is equals to number of row. Whose number of column is equal to number of row. If and only if for M by N matrix, M is equals to N for square matrix. For square matrix, M is equals to N. Example A, matrix A is equals to A, B, C, D, E, F, G, H, I. This matrix is 3 by 3 because it have 3 rows and 3 columns. Then A, E, I is the main diagonal entities or the main diagonal elements. And this in this matrix B, the dimension or size of the order of this matrix B is 2 by 2. These 2 indicates row and these 2 indicates column of matrix B. And 1 and 7 are the main diagonal entities. Here the note says that a square matrix A is equals to Aij of order n, the entities A11, A22, A up to ANN, which lie on the diagonal extending from the left upper corner. In this matrix, the left upper corner is A. To the lower right corner, the lower right corner is I. Therefore, from A up to I, that include A, E, I is the main diagonal entities. Main diagonal entities, or simply main diagonal. Therefore, the square matrix is simply number of columns is equals to number of rows. Example, matrix C is equals to, matrix C is given 3, 2, 4, 1, 6, 0, 5, 1, 8. The entries C11, 3, C22, 6, and C33, 8. This is C11. C11 means the first row and first column. This is the 6 is C22, second row and second column. The 8 is the entities of C33. That means the third row and third columns. Therefore, C11, C22, and C33 are the main diagonal elements. Therefore, find the trace of C. Simply trace of C means the summation of the main diagonal elements 3 plus 6 plus 8. That is 70. Therefore, 70 is trace of C. The note sum of entries on the main diagonal. Sum of entries on the main diagonal of the square matrix A of order n is called trace of A. When a given square matrix is calculated, when a matrix A is given, then the trace of A is calculated by using this formula. The summation of AII, but I starts from 1 up to n. Therefore, this the result of this is the so-called trace of the given matrix A. The fifth type of matrix is the so-called triangular matrix. The fifth type of matrix is the so-called triangular matrix. And triangular matrix is square matrix. What is triangular matrix? It is square matrix. Square matrix number of row is equals to number of column. Triangular matrix is divided into two. Triangular matrix two type: upper triangular matrix and lower triangular matrix. The upper triangular matrix is square matrix of all its elements below the principal diagonals are 0. All the elements below the triangles below the principal diagonals are 0. Here 1, 1 is the main diagonal elements. Below the main diagonal elements, all the entities are 0. Therefore, the matrix is the so-called upper triangular matrix. And lower triangular matrix is square matrix of all its elements. Above the principal diagonals is 0. Example, this is an example of lower triangular matrix because above the main diagonal all entities are 0 because 0 0 0 indicates the principal above the principal diagonal entities. Therefore, above the principal diagonal entities are all 0. This shows the triangular matrix is lower triangular matrix. The sixth type of matrix is the so-called diagonal matrix. Diagonal matrix is square matrix because its number of row is equals to number of column. The diagonal matrix also number of row is equals to number of column. If each of the entries not falling on the main diagonal is 0. In diagonal matrix, this definition must be always true. Aij is equals to 0 for I different from j, and Aij is different from 0 if and only if I is equals to j. When I is equals to j, Aij is different from 0. When I is different from j, Aij is 0. Here this example shows that this 5 is A11. 5 indicates A11. That means I1, J1. Therefore, I is equals to J. If and only if Aij different from 0. Here, 5 is different from 0 because I is equals to J. Here, 7 indicates 7 is A33. A33 is 7. Therefore, I is 3, J is 3. Therefore, I is equals to j, 7. Aij is different from 0. 7 is different from 0. Therefore, for diagonal matrix, this definition must be always true. The seventh type of matrix is scalar matrix. Scalar matrix is diagonal matrix. Scalar matrix is diagonal matrix whose all diagonal elements are equal. In a scalar matrix, all diagonal elements are equal. Example: A200, 020, 002. These are 2, 2 indicates diagonal entities. Therefore, they are equal. In a scalar matrix, all the diagonal entities are equal. The eighth type of matrix is unit matrix, or the another name of unit matrix is identity matrix. Identity matrix is also the same as unit matrix. Its definition says that unit matrix or identity matrix is a square matrix if all its main diagonal entities or all its main diagonal entries are 1. In unit matrix, all the main diagonal entities are 1. Here an example: I3 indicates identity matrix of order 3. I2 indicates identity matrix of order 2. Here A is equals to Aij square matrix. A is an identity matrix. Aij 1 if I is equals to j. Here I and j is equal because 1 is equals to A11. I is 1, j is 1. Therefore, when I is equals to j, Aij is equals to 1. I is different from j, Aij is equals to 0. Here I is different from j because this 0 indicates the second row first column. That means 2, 1. A21. That means the second row and first column. Therefore, I is different from j. This indicates that Aij is equals to 0. Simply in unit matrix or identity matrix, the main diagonal elements all are 1. This is all about type of matrix. And please guys, don't forget to like, share and subscribe my channel. Next we will discuss about the operation of matrix. Thank you for attention.